Okay, all right, for reset. So the 99.99998 equals 31.6 seconds. And what that is, it's an uptime meter that we have on our website that you can check at any time. That's an aggregate of all the systems that we have on service contract across the globe, not just in Texas, not just in North America, across the whole globe. All right, and actually the 31.6 seconds is usually, and it's not usually, it's because of operator error. Most of the time what happens when we have downtime, someone forgot to check their system. And they either let service or maintenance lapse or something like that, and it's just rocking along. They failed out of redundant mode, maybe, I don't know, months ago, and they didn't notice it. They didn't have the automatic part shipment to come help them correct the issue. So most of the time it's operator error. So this is a breakdown of the way that everyone else does it. All right, so if you're trying to deploy, whatever it is you're running, Factory Talk is what most of you guys are going to be running around here. You try to do it on a conventional server, you're going to have about a 99% uptime, right? 99% sounds really good until you start digging into it, right? So if you're running a conventional server, you're going to have about almost 88 hours of downtime a year. All right, that's a lot. So people start thinking, okay, well, what can we do? So most people that go to virtualization, they either think of, okay, I want to be fault tolerant or I want to be highly available, right? Highly available is here. Fault tolerant is here. This is where the numbers will show it. So if you look at the third one down, high availability cluster, that's what our competitors usually offer you. So think of like a Dell or HP VMware cluster. You get 99.95%. But that's still, you're going to get 4.5 hours of downtime a year. And that's not as a whole of everything they do, that's per cluster. So if you're running a 3 or 4 node cluster on your system at your plant or your facility or whatever, you're pretty much guaranteed about 4.5 hours of downtime per year on that system that you've got. So where we're at, the Stratus zone at the bottom, that's the 99 point all the nines. And the first number I showed you, the 8 on the back end, it changes a little bit, it just depends. Sometimes it's a 7, sometimes it's a 9. But what it boils down to is we're going to keep you up and running, right? We don't go down. Right, the 31.6 seconds is a huge difference in downtime when you're talking cost of downtime for some people I know, like pulp and paper industry is like $15,000 to $20,000 an hour. Oil and gas is usually ridiculously higher than that. So when you start talking about eliminating 87 hours, eliminating 4.5 hours, you're talking immediate payback on going to a fault tolerant system. So that's why we're here today. We're trying to help you guys get the payback on the virtualization implementation that you're trying to do. All right, so who is Stratus? You saw the why of what we do. Why we make fault tolerant servers is that right there. The huge difference in the cost and downtime. We think if you buy software applications that you buy them to run. So we try to keep them running for you. The who is Stratus. This is who we are. So for those of you that don't know us, we got started in 1980. When they first invented the fault tolerant server, they were like, okay, who's going to buy this, right? Who's going to get the most immediate impact from buying a fault tolerant server? So they immediately went to Wall Street. Those guys, they can't go down. So they really latched on to the credit card processing companies. They really latched on to the stockbrokers, traders, and all that stuff. So if you look at our history, that's where we got our feet wet. That's where we built our foundation, was in the financial sector. So much that even today, 4 of the 5 largest global credit card networks still use our solutions. We have some, can't say their names, but we have some customers that actually have us embedded into their corporate headquarters. Our team is just part of their team. That's just the way that we do it. As you can see, we kind of touch everything. When you got half of the Fortune 100, you're kind of touching a broad mix of retail, food and bev, oil and gas. So think of financial, think of industrial automation. We kind of touch it all. What we've gotten into, I would say, probably the last 5 to 6 years, is we've seen a huge shift in the demographic of our buyers. So let's see, we started in the 80s, so I would say probably the first 3.5 decades of our business was heavily weighted to the financial sector. Over the last 5 to 6 years, the industrial automation sector has been absolutely freaking booming for us. So much to the point that last year they actually surpassed our financial business. So we're doing more business now with the industrial automation market. And it has really to do with the whole advent of the connected enterprise and the Internet of Things, and the analytics behind the data that everybody's doing. Once you start getting that data and you start making smarter, better business decisions, you don't want to lose that data. So everybody's like, okay, I got to have this. I got to stay up and running. So that's kind of been the trajectory that our business is going. And so you'll start seeing the, going to the right, who are our customers. We've got some logistics and all that, but you start creeping into the industrial automation, water, wastewater. That's industrial automation, right? So here's just kind of reiterating what I just touched on. So 52% of our business last year is what we consider edge business or industrial automation business. When we say edge, think of below the DMZ, right? If you've got your network segmented where you've got the business and then, like plant floor, industrial network, or whatever, the DMZ, and we're below that, right? So FT server would be like directly below the DMZ, and then our new edge server is actually out on the plant floor or on the pipeline or something. We'll get into that in just a little bit. But this is just really kind of some of the industries that we're in right now, right? That we've been doing business with for years. So like I said, food and bev, oil and gas, water, wastewater, heavy metals, mining, all that type of stuff. If you look to the right, this is why we've been winning, right? So those of you that do know FT server and what we do and how we do, you kind of get this, right? When you buy an FT server, once you get the system up and running, you don't need IT skills to keep your system going, right? So no matter if you're running Rockwell software, Windows, whatever it is that you're running, the system it's so simple, it's so dummy proof, you don't have to have an IT specialist on site to keep it running, right? Second thing is the no unplanned downtime, which is always great. People usually get fired for unplanned downtime, or at least don't get promoted or raises or whatever like that. So the no unplanned downtime is really a feather in the cap for everybody. The predictive monitoring is part of our service offering, which I'm going to get into all this here in just a little bit. I'm just kind of planting seeds right now. That's part of our service offering. And really, our best customers, the ones that have multiple deployments of our FT servers, will tell you we're more of a service company than anything. We have a great offering, but it's our service that sets us above everyone else. And I'll get into how we do that. You'll kind of be able to digest that and be like, oh, okay, now I see what you're saying. And then really, if you look at the bottom one, this is the one, I was doing this presentation about a month and a half ago in Little Rock at the Rockwell Automation on the Move. And I was talking about the low total cost of ownership. And there was a guy in the back raised his hand. He goes, he's telling the truth. I was like, all right, great, carry on, man. Yeah, what was it telling the truth about? And he told the story about how they had 3 systems in their plant now, 3 FT server systems in the plant. And when they were getting ready to deploy the first one, they were looking at the cost of doing an FT server versus the typical, whoever our competitor, Dell, HP, something like that. And at first, they were like, oh man, this server's, it's more expensive than the other guys. Well, then he's like, I started doing the full bill of material. He's like, and I had to have 4 of those other servers. And then I had to have, licenses for every server that we were going to be running for whatever it was we were running. He said, I did the total cost of ownership on it. He's like, and you're absolutely right. He said, when we looked at it apples to apples, you guys were 66% cheaper than the other offering. I'm like, great, man. Can you say that again? Can you record it? So that's kind of the message that we're getting into. We'll get into it as we go across the presentation, but these are why we win over here to the right here. All right. So part of the reason I'm here today is to talk about Stratus as a whole, really, and what we do, but why we're doing what we do, right? So the computing at the edge, right? Why is computing at the edge so important? This really says it right here, and it's because of you guys, right? Everyone I talk to, and I talk to a lot of people every month, telling me that the business drivers they have, the directions that they're given are, we've got to be faster, we've got to be better, and we've got to be cheaper. And the easiest way I could put it, bless you, is that anymore, it's not only just a global economy, it's almost a cannibalistic economy, right? You know, and so the best way I could put it is I came from Rockwell. I had a customer when I worked with Rockwell that we were having one of these discussions one day, and they were a tire manufacturer. And they were talking about these new machines that they had brought in and how many tires they were building an hour, and how much it increased productivity, and how, I mean, it just boosted the morale for the whole plant. And they had like 3 more on order, and everybody was so excited about it. That's great, man. I was like, you know, man, it's cool to be able to, you know, beat, you know, the people in Mexico or China or whatever like that. And I'm like, yeah. It's like, not only that, but the people in Mississippi too. Really? He's like, yeah, we got a sister plant in Mississippi. You know, we want to be the best plant that's in our fleet, because if they go to cut jobs or something like that, we want them to cut it somewhere else, not here. I'm like, wow, that's great. Never thought about it like that. So not only people are competing with China, Mexico, India, or whatever, they're competing with their own sister plants within North America. So this whole faster, better, cheaper thing really hits home with the people that are living that. So how do you do it faster, better, cheaper? In the old days, it was, you know, we've got to do computing. With computing, you know, comes more data. With more data comes analytics. The old days, it was the data center. You know, centralized, regionalized data center, where you've got, you know, like an IT team or something. It might be a corporate, it might be at like a regional headquarters or something like that. But everything was kind of, you know, sent to one location. And then came the advent of the cloud, which a lot of people were really starting to adapt, and it kind of freaked them out at first, but now they're, okay, I can kind of get it. I can send my photos there. You know, I can do some other things with it too. But what we're talking about is the edge, right? So not centralized, not regionalized, not at corporate headquarters in some room where nobody knows how to get to, but like actually at your facility or at your location or on your specific machine. That's what we're going for, because there's so much that can, you know, that can go wrong, and there's so much of a lag between, you know, not having real-time data when you need it to make real-time decisions. So that's why we believe, and not only us, many people believe, that edge computing is the future, and it's going to be the differentiator for everyone. Right? The problem with that, somebody at our corporate actually said this and kind of stuck with us, is that as more and more technology is deployed at the edge, there are fewer and fewer people there with IT skills, right? So you go back to that old model I was talking about with the big data centers, where you've got all these IT people. You know, you might have 5 in one location, but they cover like a 19-state geography or something like that. As you start doing this edge computing, you know, you don't have access to those guys. I had a story like 3 or 4 weeks ago. You were with me. Where the guys were talking about, they were looking at putting in an MT server. So we came in, we did a demo for them. And they're like, man, this would be, we showed them the ease of use, you know, how simple it was. Man, this would be great. I said, you know, we had an instance not too long ago where we had an issue, and we logged a service ticket for our IT department on Monday afternoon. So they finally got back with us Friday morning. That's not very user friendly. I mean, what do you do with that? I mean, that's 4 days you're sitting there waiting on someone just to answer you. That was just, oh, hey, how can I help you? So if you're going to do computing at the edge, you've got to do it where it's so easy and so simple that you don't need IT skills to keep it running, to maintain it, or basically just once you get up to keep the status quo, right? Because once you get something, you want to keep it the same. If it's beneficial to you, you don't want it to mess up. So this is really what, I'll breeze through this one real quick. This is what we call the key technologies in modern computing infrastructure. So when you start looking at virtualization, everybody here on the virtualization wave, I'm assuming so, right? When you start looking at virtualization, basically what you're doing is you're consolidating applications to one server to increase the utilization of it, right? So that you're not expending a whole lot of capital costs buying a bunch of servers that have a low utilization rate. Well, when you do that, you know, it's pretty cool, because you can you can run multiple VMs on one server. Like I said, you decrease your overall total capital cost, If you get into the new latest, greatest thing that Rockwell's got out now that they bought in ThinManager, which I love, by the way, it makes you more mobile. To me, it makes you more secure too. I love the role-based content access that you can have with all of it. But once you start looking at this, you start realizing, okay, man, seeing more and more consolidated on one thing. There's a lot of risk in that, right? So this is the old model. One server running one application at a time, right? This goes back to the fact that this costs way too much money and you're wasting a lot of resources, right? When you're doing this on the left, you got like roughly a 5% utilization rate on your server. So you're wasting 95% of that server every time you do that. So some really smart people came up with the idea of virtualization. Now you're able to run all three on one server, but this is another quote from corporate that we have. If you're going to put all your eggs in one basket, you better have a really strong basket. Because in the old model, if you lose a server, you lose one application. That's not that big a deal. In the new model, when you start implementing this on a virtualization layer, you lose one server, you lose everything. So you're really in trouble at that point. So this is how our competitors do it. How many people have this type of deployment? Anybody? Okay, good. You probably aren't customer. All right. So this is a typical VMware cluster deployment. As you can see, 3 different servers, right? They're all networked together. So there's scripting going on there. That's a lot of engineering time and everything. It says, okay, if this dies, then it fails over to this and it restarts on this and yada, yada, yada. You kind of get all how that works, right? The issue with it is, most of the time it's not a 2 or a 3 node cluster. Usually it's about a 4 node cluster. So you have 4 different servers that you're running. You have the engineering time that it takes to set everything up, to script them all together. That's the if-then situation. If this fails, then it goes to this and all that. But not only that, you have to have multiple software licenses for every one, right? For every instance that you have, you've got to have the VMware license. You've got to have whatever the OS is, the application. You got all this software costs that add up on it, right? Remember the third slide I showed? It showed the different layers of availability. With all this complexity, you're still guaranteed 4.5 hours of downtime a year, right? And it costs more. So what we do is this guy. And that's how we do it. There's no scripting, there's no lines, networking, and all right, if this, then this, and there's no multiple licenses of hypervisors and no multiple software licenses. It's one. It's one server, one software license for a hypervisor, and then, you know, your instances of applications. So it's more simple. It's actually a higher availability. So once again, go back to that third slide, 31.6 seconds a year, and that's not per server, that's per Stratus. That's the whole company, all right? So it doesn't go down. And then when you look at it, the lower total cost of ownership, when you look at the full bill of material, you're buying one server and you're buying one set of software licenses for what you're wanting to run. So your bill of material is like this as opposed to this. Here's how we do it, right? So we've got fully redundant hardware. The way we like to describe it is it's 2 slices, okay? So it's one system with 2 slices. And what we've done is we've actually lockstep the CPUs, right? So that as you're processing data, it's actually going across both halves, but each half doesn't know that the other one's doing the same thing, all right? The easiest way to explain it is it works like your vision, right? So you cover up your left eye, your brain's still processing what it's seeing with the right eye. There is no failover, there's a failure right through. This is how we do it, right? In typical, I don't know, help me out here, Monty, typical high availability cluster, if one of the servers fails, how long does it take for that application to start up on another one?
It can be anywhere from 30 seconds to 3 or 4 minutes. It depends on what the application is, how many services are running, whether everything's a restart. And so the big difference in between what a cluster does and what an FT server does is that, you know, when the cluster fails, everything's running on a node and that node goes away. Well, all of y'all probably heard of vMotion as a component of VMware, and that's the great thing. Well, it's great unless the node dies, because you cannot vMotion off of a dead box. You have to restart, and that's what the HA component. Normally you hear the phrase vMotion HA in the same breath, because they're two halves of a solution. The HA component is what restarts on the second node of a cluster, and it can take 30 seconds if it's just a very simple domain controller or something, but if it's a SQL server or batch process or something else that has a lot of complexity to it, then it's going to take a while for it to restart. In an FT server, if something dies on one side, there is no failover because it's running on both halves. So you don't have a restart. We don't use vMotion or HA. We have FT that's at the hardware layer. So it's all running under the hood. The OS doesn't even know that it's there, whether it's Windows or VMware. It has no clue that it's sitting on a fault-tolerant box because of the way we shield everything and bind it all into a single lockstep environment.
Okay, so
Sorry.
No, you're good, man. With that same Ray Odom, we talked about this scenario. And it was like, all right, so if you have a failure in a high availability cluster, what does that look like versus an FT server deployment? And then we started breaking down, okay, how long does a failover take? How long does a restart take? How long are you flying blind? How long does it take to procure another server to be on site to replace the one that you had because it was a 3 or 4 node cluster for a reason? How long does it take to deploy that once it does show up after you've procured it? How much engineering? We started getting into it, and they're like, man, this is really kind of overwhelming. Well, with us, it's fairly simple. There is no failover, right? So let's just say there is some type of failure on the system. There is no failover. You're going to ride through it. If you're watching a Netflix movie on this, you're not even going to have a blip in the movie. Your movie's just going to keep rocking and rolling. You don't even know there's some type of component failure, right? There is no data loss. And then we're actually going to let you know that something went wrong. You're not even going to know. That's the problem with it. It works so well, you're not even going to know something went wrong. We've got to tell you, or the system will tell you. And if there is an issue, the components are hot swappable. Not hot swappable by an IT expert, hot swappable by whoever is at the site. Right?
Got a screwdriver, you're good. Got a
You
screwdriver.
don't even need
Screwdriver.
screwdriver. You just need opposable thumbs.
What?
Yeah. So we'll get into that here in just a second. But 24/7 support, like I said, we're a fantastic support company. I'll get into that in just a second. You understand what I'm saying? So these bottom two things are really usually what I try to drive the nail home with. If you look at a typical Dell or HP solution, the lifespan of those are about 3 to 4 years. About the time you get them bought, set up, installed, and you get comfortable with them, it's time to refresh again. Am I wrong? We've got ours. This is marketing. They get really worried about stuff. They put 10 plus years up here. We've literally got systems that we installed when we first invented this in 2002 that are still running. 16 years later, we don't make you refresh, right? If you want to stay with what you got, you can. Obviously, your service contract costs are going to change some because we're having to keep up with that old components that we have, but we're not going to make you refresh. Right? We're not going to make you have to redo this every 3 or 4 years, which only adds to the lowest total cost of ownership. So we talked about the bill of material difference in what we do. Well, then you factor in that say this one lasts 10 to 12 years. We just got 3 cycles out of what our competitors do, right? Because they're going to make you refresh every 3 or 4. All right, so this is the service aspect of it. All right, this is how we do what we do with an FT server deployment. So the 2 green dots let you know that everything's running fine. Okay, let's say there's an issue. All right, this says the component has failed. Here's what happens. All right, so the system, and when we say the system, if you look at our system, like I said, it looks like 2 halves of a whole. The thing that ties them together is what we call the AUL. All right, everybody loves acronyms, right? R stands for Automated Uptime Layer. All right, what it does is it constantly monitors the system, like 500 different data points per millisecond or something like that. And what it does is if there is an issue, it's going to recognize it and it's going to isolate it. Right? Once it isolates it, it's going to say, okay, it's going to know exactly what it is when it happens. Okay, the CPU has failed. What do I need to do? Well, the system itself is going to phone home to us and say, hey, site 123 has got a bad CPU. I need you to send me a good one. So it'll order itself its own replacement part, actually down to the correct revision button. So it knows exactly what's in its system. It knows where to go, when to get it. It'll set it for next day delivery. So as long as this happens before 4 p.m. Central Time on whatever day you want to call it, Monday, Tuesday, Wednesday, Thursday, as long as it happens before 4, the replacement part will be at the site the next morning by 10:30. Right? If it happens after 4, this is the whole FedEx thing. It's not going to be till the next day that it gets it. But if it happens before 4 Central, it'll be on site next day by 10:30 in the morning. At that point, so if a CPU fails, you're just going to, we call it a CRU. Each half is called a CRU, C-R-U. And it stands for Customer Replaceable Unit. Right? We did that on purpose because it's literally any customer. This goes back to, you don't have to be an IT expert to do this. So that CPU fails, system recognizes it. It's going to send out notifications. You can do it multiple different ways. You can have it email you while it phones home to us, or however you want. You can have it come up as a HMI alert on your panel view, whatever you want to do. It doesn't really matter. It's going to give you multiple different instances, however you set it up. It's going to order its own part. If you have it emailing you, you're going to know it's coming, so you can schedule whoever to be there the next day. Hey, this is a remote location. We don't even have anybody there. Bill, can you be there at 10 tomorrow so you can get this thing back up and running? That's how it works. At that point, once they ship them, the components are hot swappable. Right? So in this case, the CPU is failed. It's going to send you the whole half, the CRU, the CRU. It shows up, whoever's on site, electrician, engineer, IT guy, plant manager, it doesn't really matter, is going to take, this is where the opposable thumbs thing comes in. This half right here, these are little screws, right? You unscrew them, pop it out, you unplug the COM, and you unplug the power in the back, and you slide it out. You take the CRU that we sent you, you slide it back in, screw it back together, plug the COM, plug the power back in, and you just walk away. At that point, the system takes over. There's no keyboards, there's no mouse. It recognizes that you replaced the CRU. It resynchronizes everything automatically. It takes it back to full fault tolerant mode, and the lights are green again, right? Don't have to be an IT specialist. I mean, you don't even have to be an automation specialist. Anybody that's there can do it. And throughout this whole scenario, this is a catastrophic failure. This is the worst thing that can happen to them. You could lose a whole half. Throughout the whole scenario, you never went down. You're still processing everything with the other half. Right? You didn't have to change anything. There's no engineering, no scripting. It does it on its own. It's crazy simple. Right? So this breaks down if there is an issue, how is it recognized, right? The system's going to know it. You're more than likely not, because nothing's going to go down. So I don't know what the metrics are, but almost everybody that's got a service contract has the call home functionality working, where it's outbound only. We can't ping it. It's the way it works, all set up with firewalls and all that stuff. We have some that it just doesn't work that way. It depends upon where they're at, whether they're offshore or wherever. So you have
in the mountain in Colorado.
Yeah, in the middle of nowhere in Colorado. So you can set up with
We never
local
see or
email.
hear from again.
You can do SNMP traps.
Yeah, makes sense.
And then you can do, like I said, you can do OPC or HMI alarms, however you want to do it, right? Some people do multiple cases where they'll allow it to phone home and take care of itself, and they'll have it set up, like an alarm on their HMI or an email at the same time, so that they don't just get a shipment from FedEx the next morning like, oh, what is this? They've kind of got an idea of what's going on. So you got multiple different ways that you can monitor the system is basically what we're trying to get at. This is the really cool sizing spreadsheet that we co-developed with Rockwell. All right, so if you have an implementation that you think, all right, man, I need to do a Stratus FT server with this. We make it crazy simple to size out what you need. You just kind of go down and you click the boxes on, you know, what it is that you're wanting to run and how you're wanting to run it. And then when you're done, at the bottom in the red, it tells you, hey, here's what you need to get a quote on from your guy. So we even made the quoting part of it simple as well. All right, so that's that on FT Server. Is that a good refresher? Get that done. It took 30 minutes, man. Any questions? We good? Everybody ready to buy one? He's ready to buy one.
Which network is supposed? Analog or digital?
What's that?
Which network is supposed? Only digital?
Network. Digital?
Yeah. My concern is related to cyber crime and cyber attacks. Because generally, when the sensitive systems, if your digital supports LAN, then it will be 100% attacked by cyber. But your network is analog network. If your system network and analog network, you are free from the cyber attack because there is no expert in analog network.
Right. So network capability, analog, digital, what's?
Yeah.
We use Intel chips. It's in.
No, Intel chips. My question is network support. Generally, all the industry will be going on digital, general network, TCP/IP, right? But security purpose for the military and they are using the analog networks. Can it you support because nowadays still the Cisco switches will be support the analog. So you direct connect with the analog device and you direct connect with the systems.
I really don't know the answer to that. It's a Cat 6, traditional 10, 100,000.
It's a digital, no analog because
Yeah, it's IP, everything's IP.
Cisco switches they also support both networks.
Yeah, let me do some digging into that. I mean, most of the ones we do are, you know,
Because the analog network only the secret doors and secret services they are used.
Yeah.
Attack of the cyber.
Okay, yeah, let me do this. I know we do a lot with government. A lot with government. So it might just be something I haven't been exposed to yet because I don't really touch any of that stuff. Let me do some digging. I'll find out what you know for sure.
What is the medium that they're using from the analog connections?
It's a twisted, not 6 Cat5 or Cat6.
So it's, is it a,
What's the protocol maybe?
is it still IP addressing?
No,
All right, so you use like TwinAx or surely not going back to vampire attacks.
because what happens nowadays, everyone experts in digitalization and that network is you have any firewall, you switch the firewall, take off the firewall also.
What do you see your use case being for going with analog? Where would it
Cyber attacks, someone hacks their systems.
be? You say cybernetics?
Cyber attacks.
Cyber attacks.
Cyber attacks.
This all goes into like Stuxnet and that whole kind of world.
Okay.
And DoD especially is doing a big push right now to try and standardize everything.
Mhm.
And it gets into the whole conversation of DMZ and firewalling and all that kind of stuff. And typically, if you want to use traditional hardware right now in a DoD application, you have to be on an island.
Right.
Which is, I think, probably a best use case for this. You wouldn't end up,
Yeah, I mean, that's the
and you'd have to use their.
you'd have to create a true air gap.
Yeah,
As opposed to everybody thinks they're air gapped, and then you ask them if they can get to the internet, and they say yes, then they're not air gapped. You have to be completely isolated. So, that's interesting. We'll take that back and find out more, because I'm sure it's probably just a type of PCI card that you put in that creates the network. But then if it's not IP based, what's the communication protocol? So.
More than likely, if you're going in from a Cisco point of view, you want that to be the conduit and not to the IEDs. So that might be the other piece of it, where from a network support, it'll act as a DMZ and you want that from either Cisco or some other type of conduit and not put that type in directly into it. Because then you give them direct access, which kind of defeats the purpose.
Let's dig into it. I like figuring stuff out. Any other questions? All right, we're about to do a hard transition. Everybody ready? You good? All right, this is another thing marketing made me do. This is a bunch of people telling us how awesome we are. because of this new Edge thing.
That's slightly up.
Yes. So, okay, top one is the one we just went through, FT server. All right. Think of typical data center deployment, clean environment. Anywhere you would put another normal, typical blade server, right? The one below it is the one that you can see right here. It's called the Stratus ZTC Edge. Anybody want to take a shot at one? It's called the ZTC. He's thinking on it. Zero touch computing. All right. So we're taking the simplicity of the FT server to the next level. All right. And then edge. That's the buzzword of the day. So they do that on there too. So this is what it is. So you can see right here, we've got them stacked on each other right now just to save space. But it's actually two separate nodes that are networked together. All right. Key difference in this right now and what this is and what our FT server is at this point in time, this would be considered highly available, not fault tolerant. Okay. In March, we're flipping the switch and we're going to make them fault tolerant. But for a deployment right now, they're highly available. So just keep that in mind. So it goes back to that. Now it's a little bit higher than the 99.95. It's just because of the software that we have into it. It's more like a 99.97 or something like that. But what we're going at, right? So quick and easy. And I'll get into that in just a little bit. Wish I had the video, but the videos never work on presentation, so I hate playing them. We've got this. Really, what we're going at with this is edge computing that anybody can implement and install. Once again, you don't have to be an IT expert to do it. We were going for powering it up, getting it ready to compute in less than an hour. And as we kept doing test runs with it, it kept taking less and less than an hour to do it. So they were like, all right, well, maybe we can say it takes less than 30 minutes to deploy. So they said, all right, let's try it with people that don't know anything about computers. So they took Stratus's head of legal, lawyer. I mean, he basically knows how to type on a laptop. And they took our head of finance, and they got a GoPro, and they said, all right, here's the deal. We're going to give you a box cutter and a ZTC Edge unit, and we want you to get it up and running, ready to import VMs. And we're going to video you and time you to see if what we're preaching actually makes sense. And so they did it, and they did a test with them. And at the end of the day, the head of finance actually beat the legal guy. She beat him by like a minute or something like that. The head of legal deployed it in like right at 31 minutes. Our head of finance, she did it in just over 30 minutes, like 30 minutes and 13 seconds or something like that. Now, they don't know anything about, so they didn't know how to import VMs or anything like that, but they deployed the system. They got it ready to put, whatever it is that you want to put on. So our head of product development, he's sitting there, he's the one that kind of orchestrated all this. He was like, man, that's kind of cool. This really portrays our message of what we're trying to show. He looked over and his son is right there, the first grader. He's like, I wonder how long it'd take him to do it. So they're in the same test with the first grader, and he beat both of them. No joke, they didn't do the box cutter. They don't want to give the first grader a box cutter, but they gave him the system, and this is the sheet. It's no joke, this is the startup sheet. This is what it is, like a 5-step process. Start it up. Pass that around. That's all you need to get it up and running. All right. So the key features of it is you can deploy this in 30 minutes or less, depending upon your level of expertise. If you're doing more than one of these, you're going to do it pretty quickly. Eventually, you're going to get the hang of it. Once you deploy it, it's ready to roll. It has built-in virtualization. Okay, there is no need to go buy VMware or Hyper-V or anything like that. The virtualization layer is built into it. Automatic protection, automatic site recovery, hot swappable nodes. Okay, what that means is the system itself, much like our AUL that I was talking about earlier, the Stratus Virtual OS, what they're calling it right there, is a self-protecting layer as well. So it monitors the system constantly. right? If there's ever an issue, same scenario, it's going to notify you that there's an issue. But at the same time, since it's two separate nodes, say you've got 3 or 4 virtual machines sitting on these. What's going to load balance them out, and you'll see that here in just a little bit on the user interface. It'll load balance it out to where the system works the best way. Right? If there's some type of issue, say there's a VM running, clear that out. Say there's a VM running on the left one and there's 2 running on the right one. If there's an issue with the left one, the system is going to notice it, and it's going to actually pull that VM off the left one and move it over to the right one and let you know, hey, there's an issue with that node, you need to replace it. At that point, there is no component swap or anything like that. You just take the whole node out. So you unplug the COM and the power from the back, you replace the whole node, you plug the COM, you plug the power back in, and then you walk away again. The system resynchronizes itself. Once it resynchronizes and redoes all the data that was on it, it'll actually reload balance by itself as well. So this is a completely hands-off edge computing platform is what we went with. So this is what the front looks like. So you've got your indicator lights, HDMI that you would plug a monitor or something into it, whatever. The back is where you've got all your NICs. USB ports, all that type of stuff. So back to what we're going to. We're going for crazy versatile, rugged compute environment, right? So this doesn't have to be a clean room deployment. You can really put this anywhere. It's the temperature range right now is negative 40 degrees Fahrenheit to 140 degrees Fahrenheit. So you can put it out on the plant floor. You can put it in a shed in the middle of the desert. That's where the pipeline application is or something like that. From a humidity standpoint, it can withstand up to 95% humidity, and we've actually rated it for vibration too. It can handle up to 3 Gs of vibration as well. So, our best use cases we've seen so far is think of like drilling rigs, pipeline, water, wastewater, plant floor type visualization or thin manager deployment, stuff like that. That's really what we're going for with this. From an installation standpoint, it's DIN rail mountable, so if you want to put it in a cabinet, you can mount it on a DIN rail within a cabinet. If you want to just lay it on a table or mount it on a wall, it really doesn't matter because it's rugged. I mean, there's no moving parts and it's all solid state. So there's no fans. You've got the heat seat going around it. It's vibration rated, very wide temperature range. So it's really something you can just kind of deploy and not have to worry about. I'm trying to think. Oh, power. Yeah. So from a power standpoint, you can run it with the bricks that come with it, but most everyone we've ran into that are putting these out there just run them off 24-volt DC, whatever's in their cabinet that they've already got. I'm trying to think what else.
You have 12-volt options that are on the power.
What's that?
You have 12-volt options as well.
Yeah. What else? Munzie, anything I'm missing? That's it. Oh yeah, forgot about this. So there's 2 nodes for reading. And one of the coolest reasons is because they don't have to be beside each other. They don't actually have to be in the same building. They're split site applicable. So one of the coolest things I've seen is we've got, like water, wastewater companies like, oh man, put one in the water side, put one on the waste side, or if there's ever an issue, you don't know what's going to go on water or something like that. It'll just spill over to the other one, and we don't lose anything because it's going to restart from where it was at. We don't lose the data and all that, and we can just replace the node at our leisure whenever we want to do it. We've seen instances of where they're wanting to separate them from put one in a clean room area, put one like out on the plant floor if it's corrosive or something like that. So there's lots of different use cases on how you want to do it. We've tested it. There's a 25 miles. We've tested it up to 25 miles. And what we found out is that it'll do it, but it's all dependent upon the latency of your network. It depends on the speed of your network. So if you're wanting to do something like that, man, you're going to have some kind of crazy network speed to get it done. But point is they don't have to be in the same area or even in the same room.
10 milliseconds is the general. If you've got 10 milliseconds or faster or lower latency, then you're good.
So the second bullet there, the seamless recovery within 5 minutes, that's worst case scenario. So to us, a worst case scenario is a catastrophic failure of one of the nodes. Right? You can have like a drive issue or something like that internal, and there's not going to be that at all. It's going to notify, hey, you got a drive issue. There is no failover. If there's a catastrophic failure on one of the nodes, it will fail over to the other nodes, and the time that it takes to restart it on the other node, catch the data all up to where everything can resynchronize and all that is about 5 minutes. So that's the aspect of the high availability versus fault tolerant that I was talking about with this to the FT server. Now keep in mind, this is what we're calling the 100i. When the 110i launches in March, we will be flipping the FT switch on it. So that'll actually go away. But most of the customers that we've talked with so far, that's really not like that big a deal to them. They're like, man, this is going to be running some compute for me, but it's not going to be like a critical compute where I've got to have visible. 5 minutes is cool. That's really kind of feedback we've gotten so far. Yep, so same scenario from a service aspect. The hardware self-monitored by the virtualization layer that we have integrated into it. The system is self-diagnosing, so it's the same scenario as the other one. It's going to recognize an issue. It's going to notify you that there is an issue. Same scenario of simultaneous notification. So if you want to email yourself and have it phone home at the same time, you can still do that. I'm trying to think. From the parts replacement, like I said, it's crazy simple. There's no component replacement. It's just a node replacement. So if there's an issue with one, you just unplug it, replace it, plug it back in, and then walk away. You know, there's no keystrokes or anything like that you got to do. So this is the breakdown of the differences between the ZTC Edge and the FT server. And I just want to kind of show you that when you look at the deployments of what you would do with a ZTC Edge versus an FT server, you've got to really look at the details of everything, what it's made for. So the easiest way I can put it is the Edge is almost like a environment agnostic. It doesn't really care. You can put it in a clean room, but it's rugged. I mean, it's made to go in dirty places. The FT server, you need to put it in a clean room. I mean, that's the system that you're going to be running, that it's got critical systems on it. It's a typical server. It's got moving parts and all that. You don't want to put it somewhere that's not healthy. When you look at the physical cores on the chips, that are in it, the ZTC Edge has 4 hyper-threaded cores. All right. So one of those is for the system itself. So you have 7 available. So the wheelhouse for this is running, somewhere between 2 and 4 virtual machines. That's really what this is made for. The FT server is scalable, so it's configurable. You can make it do whatever you want to. You can actually stack them too. You can run as many virtual machines as you want to. If you can think of it, we can configure it and sell it to you. That's kind of the way we look at it. Right now, highly available, soon to be fault tolerant, always fault tolerant. And that's about it. The installation is really the key. ZTC Edge is designed to be deployed by you guys. The FT server, you really need our assistance to start it up. Right? After we help you get it going, we walk away. You don't really need us anymore. It's just kind of the way it is. Just keep your maintenance contract going. So, and man, I think that's so that's it. So, anything that's like Rockwell, so anything automation career, Rockwell automation on the move, these type of things with Rockwell distributors, user conferences, we're usually going to be at it. It's just because we're an Encompass partner of Rockwell's. We work very well in their environment. If you want the sizing tool, you can always reach out to me or Brian or Joe or whoever. If you don't want to do that, you can go to our website. You can actually download it off of our website too. The link right there, and I'll provide this PowerPoint to everyone through Brian if you want to send it out so you guys can have a look at this later. You can learn more about our ZTC Edge solution on our website. And then anyone here, if you are interested in becoming a certified solution architect for Stratus, we have a path forward to do that with you as well. It's basically just some online classes that you do with us. There's a couple different levels. You can become a certified solution architect. You can become a certified engineer. It's just different steps to do if you're interested in that. And then, man, I think that's it. Ooh, okay, I gave you a whole hour of your life back. That's awesome. So, my name is Jeff. I cover, to keep in mind, so it's from Denver, essentially to Alabama is the territory that I cover. So anything Reynolds I have from a Stratus perspective. And at this point, I'm going to hand it over to Munzie for a few minutes for those of you guys that are interested to kind of take a look at the Edge product. We've got some type of batch factory template from Rockwell pulled up on it. And we've got the user interface on his computer. So you'll be able to see it on these two screens here. And he can just kind of talk through to you, how we've designed it. The UI is web-based, so you can pull it up from wherever after you deploy the system. And I'll shut up and I'll let him start talking.
So if you're not a stock group, is that stock share?
You start.
Okay. Supposed to sign in with my thing on this. I didn't share. I was not sharing before.
Oh, you said, yeah, good.
Do I do this or do I do that? That should be up there. I did download and already did that. Do it again.
Yeah, it should run.
There you go.
And then, I get sign in with whatever you had set up.
Yeah. Did you create an account here? Have you used any password to sign in? No?
Yeah.
You were in it. So I
I
made
was
you,
watching, yeah.
well, I made you a presenter.
Oh.
And you don't. Try to make you a presenter again. Can you share screen on that now? Let me show you something. So you're still in the browser, you want, pretty sure you want to download.
So I did that. I wonder why I've got to log in and he didn't.
You were already in it because it made you a panelist. So I don't know where that was. Yeah, you're a panelist.
Okay.
Um,
So I got to start over.
You can try again, yeah. Topic. just, on the bottom. Yeah, yeah.
It's a bridge, bro.
Taxes. I think those were there just to see how stupid you could be.
What's your mother's maiden name? There you go. Get your,
Face only one.
Stop video and then share your screen. Yeah, you're a panelist, so you should be able to. Very good.
those of you on. Boom.
Okay. That was a lot. Okay, so something to understand, this presentation is always weird now because we've been doing FT Server for, however many years and talking about its benefits over clustering. And now we somewhat are marketing clustering. But there's a difference in the way we do it and the way everybody else does. And it's much more simplistic and it's much more efficient. And the reason is because we own the operating system. ZTC runs a Linux-based operating system built on CentOS and KVM. VMware kind of is the same thing, but most of your VMware clusters for your all's deployments are going to need shared storage, and you're going to need switches, and it gets much more complex because of all the things you've got to have in order to make vMotion HA work right. They do have a vSAN type solution that you can use, but performance-wise and for your IOPS and everything else, we found that a lot of the scenarios don't function quite as well, and it becomes more convoluted in the way you deploy it. You still have to have a lot of IT understanding in order to deploy a VMware cluster, even in many cases, a Hyper-V cluster. So because we own the OS, it's our IP, we were able to create this out of the box, ready to go, and linked up, and we took hardware that we knew and understood and built the OS purposely for that piece. And so what you'll see is that we've got two nodes and we don't have shared storage. It's got two SSDs inside and we keep them in sync. And the way we've built the operating system is that it basically, even though it's two separate physical nodes, it still is an overlay. And from a licensing standpoint, you still just license it as one system. So in a cluster, you've got multiple nodes that you're putting licensing on. In this one, you need to put a Windows Standard Edition license on this one and a Standard Edition license on this one, and you've now licensed up to 4 VMs for the entire solution. You can run all 4 on one, you can run 2 on one, 2 on the other, 3 in one, whatever your mix is, as long as it doesn't exceed 4, Microsoft's fine with it. And you don't have to have a VMware license because it's our OS, and so you don't put VMware on it, so it comes with it. So whatever the price is that you get, you don't have to start adding all these other things onto it. And I go through that so that you understand what you're looking at here, that from a resource standpoint, you're still looking at deploying. Okay, that's the presentation. That's actually me. From a storage standpoint, logical disk 0. And let me tell you where I am. So on the left side, you've got your access to various views. And this is the UI. You get there by hitting an IP address, typing in the username, password. Default is pretty standard admin. But that can be changed. Dashboards here. Disregard the yellow bang. It's because the system is set to phone home and we don't have it set to external network, so it can't do that. So those are all they are. They can't communicate with our licensed server to verify that it's licensed. System environment here.
I was just wondering, how long does it run in error like that until it like shuts down? Or...
Well, so it's got a 30-day license out of the box, and so as soon as we get to a place where when he gets at home and can turn it on and connect it to his network, it'll sync itself up, do the license, or we can phone in and.
It's not gonna kill it though. Like, if
30
you don't do that, it's not
Yeah.
gonna shut down.
Yeah, you got.
It's just an alarm saying, hey, this is not coming home. If there's an issue, it's not gonna order its own replacement part type thing.
Exactly. When you set the thing up, each node has an IP address, but then the system as a whole has an IP address. So in this particular case, node 0 is 192.168.0.1. Node 0, node 1, dot 1, dot 2. It can't do a 0 as a dot, and they call it anyway. I hate that. The system's IP address is dot 10. And that's how you access it. So you don't access each individual node, you access the system. So that if something fails, it's basically presenting the same IP address on both sides. You've got, the system has 4 of 8 vCPUs. The system has 31.9 gigabytes of storage and 468 gigabytes, 31.9 gigabytes of RAM and 468 of storage. So as you see, it gives you just one node's worth at the system level, even though you come down here, you can see where the VMs are running and what resources they're taking on each node. Does that make sense?
The reason we do that is if there is an issue, if there is a failure, you've got to have the system sized so that if it fails over, everything will still run on just one node. We don't want you to oversize it, because it's got all the storage and RAM on, and if something happens, we'll actually won't let you run anyway. The system's smart enough to tell you, hey, this ain't gonna work. But the point is, if there is a catastrophic failure on one of them, everything that you have on there will run on just one until you replace that bad node.
Exactly.
Have we done a similar sizing tool for
It,
Yep. I'll
As
send it to you.
would you rolled out several versions and you got 10. That's the latest one is 10.
Yeah.
So now that said, the configuration doesn't change, but it helps you stay within the tolerance.
And basically, if you go to configure something, please, and it won't fit on this, it's a default. You need to go to 2810 F27.
So this is the overall system health. It tells you where everything is and what's being used where. Right now, node 0 is where the VM that we've got deployed is located. These are just preferences, general information of what we've got.
So this is where you can set your alerts, your, however you want to do it,
Email alerts.
email alert, SMP trap, whatever, everything that you need is going to be on this user interface from the web page.
There's the alert history, very similar to every other log looking type device. You click on one, it brings up the information down here. They're the actual audit logs themselves. And support logs you generate it. If we may say, we need it. If you don't have it phoning home and it doesn't send this, then we may call and say, all right, we need to send us a diagnostic log. So you go in here, create it, export it, and email it to us. So here's your resource information. Up here, node 1 is primary right now. That's the top node. Node 0 is on the bottom. The reason node 1 is primary is because earlier during our testing, we pulled the plug on one, failed it over to make sure that it was operational. The 6-year-old did beat me, I'm afraid to say, but he didn't have to configure a brand new switch in order to do it. Still holding it.
Don't try to play it bad either.
It was, yeah. Anyway. You can't fix it. So node 1 is currently primary, and that's where the VM is running. If you go to the virtual machines link, we've got one. It's in HA protection, high availability. You go down here, it's a summary. It's a KVM Windows Server 2012 R2. It's got 4 virtual CPUs and 8 gigs of virtual memory. Automatically load balance. You can manually place it. So this is where he was talking about the system will load balance based on resource allocation. So if you're building one and you just want the system to drop it wherever it's got the freest amount of space on the side or on each node, then it'll do that for you. Or you can say, I want this one to run on node 1 as its primary, and then if something fails, it'll move it to node 0. Or if you want it to normally live on the other one, you can set that. So otherwise, it'll put it where it needs to go. Boot options, storage volumes, networks it's attached to, and then of course CD drives. You need to bind a CD to it, insert a CD or attach. You can use, it's got USB ports, so you can plug them in and get an external. You just got to make sure you know which one you're on. Console. So this is what we're running. Instant Fizz Factory Talk USD client. There we go. Okay. And so this is a demo that Rockwell has. Rockwell application specialist. I really don't know what I'm doing.
Please take over.
There you go, that's running. And so it shows you what happens as it happens. Filling information, so.
All right, let's get to the cool stuff. Let's start yanking.
All right. You want to play, huh? All right, so let me minimize this. What I'm going to do. Hold on. So as you can see, everything's flashing here. Everything's going. This is node 1, and just to validate, calm down.
No, I'm saying it's running on top, right?
Yes, it is. So if you look at summary, serial number is 0046. And if you look on the bottom, that serial number there says 46. 45 is the one down there, just to show you it's not smoke and mirrors. Okay, you may pull the power out of the top node. All right, so we just downed the top node.
Still says good.
All right, so again, it is a cluster, so it's got a refresh cycle. It's got to recognize, even though it knows something's happening, it's doing something, the UI has a 15, 20 second interval as it rescans and gets data. So it'll eventually a red X. There you go. All right, so just posted that the networks have a problem. Private 0, which is, and y'all come around and take a look at this when we're done here. Setup for this thing is really pretty easy. You've got 2 network cables that are private that go between the 2. They're the heartbeats. One is yellow, one is blue. blue one has 2 stars, or has 1 star under it, the yellow one has 2 stars under it. If you're colorblind, you can still set these up. Blue and yellow are 2 that are easiest to see, I think, for colorblind, and you just look at the dots. You connect the
Log back in.
single dot. Yeah, so it just switched it because it's 10 is still the IP address we talked about earlier, but it just moved to this one. So I've got to actually log in again to see it in order, because now the website's being presented from Node 0. So everything did move. The virtual machines. Look at here. The VM's now moved up to here. So where did my
Console.
Yeah. So we'll have to, yeah. So go to the machine. Have to restart the console because I had to re-log in. So it is working. Everything's functional. So however long that was between when he pulled the power, we're back up and running again. Now, as with a clustered solution, it's a restart. So whatever it was monitoring, it's because this is the demo system, it's not going to be in the same state because it's not getting live data, it's running a script in the background. Where this live data, where it was showing all those filling, whatever, once it restarted and you click back to wherever that was that you were, you would see the current status of that process because that's a live process. This is not live, it's Memorex, so we got a little bit different. But that said, we're still back in operation again inside. Were we at 60 seconds? 60, maybe 90. So there's not many clustering, high availability solutions that you can set up, configure in about 30 to 35 minutes. And then we can import VMware OVF files or OVA files. We convert them to our format on the fly. So as long as you've got access to them, that's how you can deploy your VMs. So you don't have to build from scratch. You can build from scratch if you want to. We have the ability to mount ISOs and build a VM environment just like you normally do. So if you know how to build virtual environments now, then you can do that on this just as easy. If you've got a customer that has got virtual VMs that are production and they're already using them and they want to move it to this, because we can convert VMware files, that's easily done and they don't have to recreate the wheel. So it took us, outside of once I restarted everything or whatever and started the install and I got my IP scheme figured out, about an hour for us to be fully up and running high availability. We were ready to go with this importing the OVF file here and setting everything up. So there's not many solutions out there that can do that. That is one thing. Remember, these are servers. They look like workstations, about the same size, but it's actually a server. The only thing you get if you plug in is the UI. So if you want to actually look at the server itself, then you've got to log in through RDS or whatever. That's how you manage your VMs, just like you would, or your console here. But small HMIs, thin manager, something out in the plant.
Any questions? You did good.
It did break this time.
I didn't see any class 1 or hazardous ratings on these. Is that any plans?
It's not class 1, did too. I don't know if it can get there.
Yeah, it's a server, so
Yeah.
it's on. Yeah, so it's,
We've had discussions that came up with a couple different oil and gas customers. And they're like, man, we'll just put it outside of range.
Yeah, it's not, I don't think there's any server that's class 1 to 2 today, so it's not like.
No. We can't avoid that flag.
But it is a lot bigger than that.
Yeah, that was just curious. And there's safe areas everywhere. And plants and stuff.
So yeah, that's it, man. We, like I said, we were going for simplicity, but ruggedized, and I think we're there. There's a lot of cool features about it, but at the end of the day, I mean, it's to Lindsay's point, it's an industrial server, right? It's not an industrial PC, because, you can do virtualization with it, you can run multiple VMs on it. And it is a set it and forget it solution, which is what we designed it for, is what we wanted it to be. And that's it, man. I mean, if you guys have any questions, we're gonna be here for just a little bit. If you wanna come down and check them out, we'll play around with the UI or anything like that. It's kind of open for you guys, however you wanna do it.
135.
How about the FT version affect the CPUs
We're about 30 minutes away.
So you're giving away a lot more information than I know we were allowed to give away, so.
Trying to.
You were told you could, okay.